All right, good day, everybody. So today we're going to go ahead with the word problems in the solving linear systems unit. Word problems are kind of interesting. They're very, very fun. However, there are no method that specific method that you can learn. It just basically you gotta use whatever method that works for you. We're going to use the method of systems of equations. That makes it a little bit easier so that we don't have to waste time. It's very efficient, and that's what we're going to use. So a couple of steps. Number one, first is that the words, the sentence that you get, you have to translate it into the equations. Okay, make it an equation out of what you read, and then once you have the equation set up, then you have to solve the system. Simple as that. So let's go ahead and look at example 1. You have sum of two numbers is 25. The sum. What does sum means? Sum means adding. So the first thing you have to do, we have to label. We have to label what is what. So label or give it a title or give it a name. So let's suppose x is the first number, and let's call y is the second number. Okay, now I just use x and y. You can use a and b. You can use whatever variables that you like. It doesn't matter, but we need to actually make sure that we name these so that we can set up our equations properly. Okay, let's go through and then do the translation. Sum of the two numbers. Very good. Equation 1 is basically x plus y, because you're adding them. It is the difference of the two numbers. Now in this case, it doesn't matter which one is first, which one is second. You can simply say the difference is subtraction. X minus y. That's equal to 7. Simple as that. Simple as that, the difference of the two. And the question is, what are the numbers? Notice that we have the system of equation, and now the method that you're going to use is whatever method you like. The easiest method, the most efficient method. So let's go ahead. I'm going to use the addition subtraction method. That's just easier. In this case, I'm going to basically add equation 1 and equation 2 to get rid of the y values. Okay, so x plus x, that will give me 2x. Y plus minus y, that's 0. And 25 plus 7 is 32. Divide both sides by 2, and I'll get x equals to 16. Great. Once I get 16, you take that 16. Remember that the sum of the two numbers is 25. So I'm going to sub into the first equation or second equation. It doesn't matter. So 16 plus y equals to 25. And then once we sub it into the first equation or second, we solve for y. What is y? Y is 25 minus 16, and that will give us 9. Okay? And so in terms of the coordinate part, even though it's not a graphing solution, but it's 9, 16, but the two numbers, x is 16, y is 9, you can double check and you'll get it. So not all equations or word problems are basically giving you a nice set of kind of a system like that. Sometimes it gets a little bit more complicated. So look at the second example. The second, so basically we got two numbers, you add them, you get 7. So again, let's do x is the first number, and y is the second number. Okay, so first part, very simply, x plus y is equal to 7. But the second part of this sentence says 3 times one number is 15 more than the other one. So 3 times one number. So let's say, so the first one is x, so 3x It says is means equal to, so this is the part where you have to decode, is 15 more than the other number. So if the other number is y, so it would be 15 more than the other number. Okay, so simple as that. That's how you set that up, and then you're gonna go ahead and solve it in however method that you wish. So in this case, I went ahead and changed the format of the second equation like the first equation, and then in this case now I can easily add the two. Very easy. So equation 1, equation 2, I'm adding the two equations. X plus 3x, that will give me 4x. The y's cancel out, and then the last piece would be 7. Somehow I missed that. Okay, and then once you add the two equations, you notice that the y and y cancels out. You add them, you get 4x equals 22. Divide both sides by 4. X is 5.5. Great. Now you take that and then plug them into, so sub into 1. So x plus y equals to 7. So 5.7 plus y equals to 7. Y is equal to 1.5. And then you will double check, is that true? So sub into equation 2 is, so here is the thing, is 3 times 5.5 equals to 15 plus 1.5 is, so basically that is 16.5. Is that equal to 16.5? Yes it is. Yes it is. Therefore you're done. Okay, so basically you're changing this word problem into the equation, system of equation. Then you go ahead and solve the system in whatever method, however you like to solve this, using the elimination or substitution, it doesn't matter, and then you double check your answer. So look at the third example. A little bit more, again, complicated, but that's okay. We're gonna go through the question systematically. So let's first translate. The cost of 4 liters of oil and 50 liters of oil gasoline is $52.50. So first we have to label. We call this A being the cost of 1 liter of oil. Now the way you know what that is that you always look at the what is it that they're asking you to do at the end. They're asking you what is the cost of 1 liter of oil and 1 liter of gasoline. So you have to name those. So A is the cost of 1 liter of oil and B is the cost of 1 liter of gasoline. Now we're going to go ahead and write the equation. So here it is. So 4 times A for the oil plus 50 liters of gasoline, let's call that B, which we did. Together the cost is $42.50. That makes sense. Okay, so 4 liters times, let's say $1 for oil, that would be $4, and 50 liters times gasoline, let's say $1.50, whatever that is, you add them all up, it should get you whatever the value is. In this case, it's $42.50. We don't know what the AB is at this time. Let's write up the second equation. The second equation, we have 3 liters and 35 liters, so would be 3A plus 35B. That would be equal to $30.30. Great. From this point on, you just go ahead and use whatever method that you like. I suggest you do the substitution, sorry, the elimination method. So basically you want to get rid of A probably first, because it's just easier to come up with the lowest common multiple. And in this case, I would actually multiply the top equation by, remember the LCM, in this case is 12. So multiply the top by 3, the bottom by 4, and then rewrite and then go ahead. All right, so that's what you will get. Very good. And then in this case, you have to subtract. Okay, equation 2, take away from equation 1, that's 0. Then you get 10b equals to, in this case will be subtraction $6.30, I believe. And then divide both sides by 10. Divide both sides by 10. and B equals to 0.63, and in this case is a dollar, so basically you're looking at 63 cents for B. That's the gasoline. And then substitute back in to one of the equations, get the value of A. So now that we have the original B, we plug it back into the original first equation. I like to do that, original first equation, just to make sure. Here it is, and I substitute a 0.63 for B. So here's the B value. I'm just going to substitute that right there, right? And then I do the math. I get 4A equals to 11 when I do the math and bring everything on one side. And then final part is dividing everything by 4, and then A equals to 11 divided by 4. And that is $2.75. Okay? And then once we have that, you need to check your answer. Always check your answer and make sure that you plug it back into both equations. And usually you're going to use the original. So 3A, so if you just check the 3A plus 35B equals to 30, if that works, that means everything else is okay. And in this case, it does. And here's the check. So plug numbers in for values in for A and B for the oil and the gasoline, and then you do the math. Does it equal to $30? $30.30? Yes, it does. And that's it.